First of all, I welcome all the students and the participants who are attending this live lecture. See this, in this today's live lecture, we shall discuss one theorem based on equation with the variable separated form. See this, one theorem based on variable separated form. Actually, this is the lecture number 45. Now, see this is the first bit of this unit number 4 or in this chapter number 4. Actually, totally this chapter is based on existence and uniqueness of a solution of a first order differential equation. That means we have to discuss only the first order differential equation, and in that first order differential equation, actually we have to find out the solution of a differential equation. There are different methods for finding the solution of a differential equation. We have discussed it. Then we shall discuss what is meant by exact differential equation, then successive approximation method, and then Lipschitz condition. Now see this, the general differential equation, we have seen this concept deeply in last lecture. The general differential equation in first order and first degree is dy by dx is equals to f of x comma y divided by g of x comma y, where f and g are the functions of x and y. That equation may be written in the form of a p dx plus q dy, where p and q are the functions of x and y. This is called as a general differential equation. But for the solution of the first order first degree differential equation, it may have required some specialty conditions. According to that special condition, we can find the solution of, we can use the solution method for that function series, you must know. So the different solution methods are as follows. If the differential equation in the form dy by dx is equals to f of x divided by g of y, means f is a function of x, again y is a, g is a function of y only, then we can solve this differential equation by variable separation method. If the differential equation is in the form dy by dx is equals to f of ax plus b plus c, that means the linear term with constant, then such type of a differential equation can be solved by putting ax plus by plus c is equals to u. The differential equation of the form dy by dx is equals to f of y by x, then also we can solve this differential equation by putting y by x is equals to v, and here you have to again you have to use the variable separation form. The differential equation of the form dy by dx is equals to f of x comma y divided by g of x comma y. F and g are the functions of x and y, but they are particularly homogeneous functions. अगर f and g दोनों भी homogeneous अगर function है, whatever may be degree, then also we can solve this differential equation by putting y is equals to vx, that means dy by dx is equals to v plus x du by dx, and again by separating this we can solve this differential equation. Then the linear differential equation, the differential equation of the form dy by dx is equals plus py, which is equals to q, where p and q are the functions of x only, then the solution of this differential equation is y is equals to e raised to minus p dx in a bracket in integration q into e raised to p dx plus c, in this way, where here we can write in the shortly y into integrating factor, which is equals to q into integrating factor dx plus c. म्हणजे हा जो फॉर्म्युला आहे ना, हा फॉर्म लक्षात ठेवायला थोडा हार्ड जातो. इट इज डिफिकल्ट टू रिमेंबर दिस फॉर्म, so we can use this simplified or for the purpose of remembering this formula, we can use y into integrating factor, which is equals to q into integrating factor dx plus c. So next, the general differential equation, we know that y dash equals to f of x comma y. In the symbolic form, the general differential equation may be written in the form of y dash is equals to f of x comma y. then function is in terms of x and y. It may be in the division form, multiplication form, exponential form, whatever may be, that is f of x comma y. If this form can be written in the variable separation form, then we have to write. So its equation, see this, the explicit, where f is some continuous function only, in rather special case it is possible to find the explicit analytic expression for the solution. We can write in the form of analytic coefficient. This first order differential equation can be written in the form of analytic coefficient, that is y dash is equals to g of x y plus h of x, where g and h are the continuous function on I, which are also analytic. Then its solution can be written as this. Okay. Now the equation with the variable separation form. Next, second bit, equation with the variable separation form means हमारे पास अगर जनरल डिफरेंशियल इक्वेशन y डैश इज इक्वल्स टू f of x comma y है, but it may be separable variable separation form or it may be not variable separation form. अगर इसको आपको वेरिएबल सेपरेशन फॉर्म में लिखना है तो पर्टिकुलरली f of x comma y must be g of x divided by h of y. मीन g is a function of x and h is a function of y only. अगर हम f of x comma y इस तरह से रिप्लेस करते हैं, that means y dash is equals to g of x divided by h of y. Then we can say that the given differential equation is in the form of a variable separation form. This is the concept of a variable separation form. म्हणजे x चा पर्टिक्युलरली g of x म्हणजे एक पर्टिक्युलरली x चाच फंक्शन पाहिजे, h of y म्हणजे तो पर्टिक्युलरली y चाच फंक्शन पाहिजे. असा जर फंक्शनचा फॉर्म असेल तर आपण व्हेरिएबल सेपरेशन न सॉल्व करू शकतो. आता त्यानंतर आपण एक थेरम पाहिला, आठवतंय का तुम्हाला? पहा थेरम. व्हॉट इज द थेरम्स हिअर? स्टेटमेंट ऑफ दिस थेरम इज सिरीज. आता थेरमचं प्रूफ घ्यायचे, फक्त मी त्या दिवशी स्टेटमेंट लिहून दिलेलं आहे, परत एकदा स्टेटमेंट वाचतो आणि मग मी प्रूफकडे जातो. ठीक आहे. लेट g and h be the continuous real valued function for a is less than or equals to x is less than or equals to b, comma c is less than or equals to y is less than or equals to d. Means we have given the domain of x and domain of y respectively of the equation h of y, which is equals to y dash equals to g of x. म्हणजे मला सांगा बरं, हे व्हेरिएबल सेपरेशन फॉर्म आहे का नाही? h of y, चला जे ऑनलाइन आहे स्टुडंट सांगा, h of y which is equals to into y dash which is equals to g of x. हा जनरल फॉर्म आहे का व्हेरिएबल सेपरेशनचा फॉर्म आहे? नाउ यू टेल मी स्टुडंट्स. if g and h, capital G and capital H are the functions such that derivative of capital G which is equals to small g, derivative of capital H which is equals to small h, and c is any constant, then we can write the solution of this differential equation in this form. म्हणजे हे सोल्यूशन आपण कशा स्वरूपात लिहू शकतो? h of y which is equals to g of x plus c. This will be the solution, or we can write this phi. Phi will be the solution of the differential equation. Y means again the phi. Phi will be the solution of the differential equation. अशा पद्धतीने हा थेरम आपल्याला प्रूव्ह करायचा आहे. ही थेरमची स्टेटमेंट आहे. ओके. Now we can write this proof of this theorem first of all, then we shall move towards. Okay, अनुराधागिरी, मोहिनी, तृप्ति गौड़, मनीषा माळी. ओके. yes, समरीन खान. ओके. पुजारी. Okay. Now proof. We shall prove this theorem. Proof. Okay. Proof. We know that the general differential equation in the first degree, first order is, suppose y dash is equals to f of x comma y. Now we know that now it is said to be variable separation form. See this equation is said to be variable separation form, when f of x comma y can be written as f of x comma y can be written as g of x divided by h of y. सारिका पराळे, ज्या ज्या स्टुडंटनी आन्सर सांगितलेले आहेत त्यांचे स्क्रीनशॉट काढून थोडं पाठव माझ्याकडं, आज पाठव. त्या दिवशी स्क्रीनशॉट पाठव म्हटलं तर तू पाठवली नाही त्या दिवशी. सपोज दिस इज इक्वेशन नंबर 2. सो वी कॅन राइट दिस इक्वेशन 1. आता f of x can be replaced by g of x and h of y, where g and h are the where g and h are the functions of single argument, single variables, or we can write g is a function of x and h is a function of y only. Therefore equation variables. So therefore equation 1 can be written as तर इक्वेशन 1 कसं ठेवलं जातं पहा, y dash which is equals to g of x divided by h of y. Okay, so we can write this in the form क्रॉस मल्टिप्लिकेशन करा. याला क्रॉस मल्टिप्लिकेशन घ्या म्हणजेच दिलेल्या फॉर्म मध्ये येतो. थेरम मध्ये जो फॉर्म दिला ना तो येतो h of y into y dash which is equals to g of x. Okay, so suppose this is equation number 2. Now this can be written as h of y which is equal into y dash means actually dy by dx which is equals to g of x, because we have to write this equation in the variable separation form. See this, how to write this equation in the variable separation form. Replace this f of x comma y, because f of x comma y is a function of mix x and y. If we replace this f of x comma y, then our general differential equation becomes g of x which is a purely function of x, h of y which is a purely function of y. Due to this replacement we can get the variable separation form. That means we can separate the variable. So we can write this equation again in the form h of y into dy which is equals to g of x. We can write g of x into dx. This is the complete variable separation form. Variable separation form इसका मतलब क्या है, अगर हम टोटल x टर्म वन साइड को कलेक्ट कर सकते हैं, टोटल y टर्म अदर साइड को कलेक्ट कर सकते हैं. दैट मीन्स ऑन LHS देर इज वन कंप्लीटली वन वेरिएबल, function of one variable, and on the other side we can collect the function of other variable. See this in this equation, the total terms of y are on left side, total terms of x are on right side. That means it is possible to separate the variable on left side and right side. So the given form is called as a variable separation form. अगर इसी तरह का फॉर्म है, अगर f of x, y g of x डिवाइड बाई h of y इस फॉर्म में होता है तो हम वेरिएबल सेपरेट कर सकते हैं. किसी भी प्रॉब्लम का, कौन से भी प्रॉब्लम का वेरिएबल सेपरेशन होता है ऐसा नहीं है. वी आर रिक्वायर ओनली इन दिस फॉर्म, देन वी कैन सेपरेट, अनलेस वी कांट सेपरेट. आता व्हेरिएबल सेपरेशन झाल्यानंतर, हे व्हेरिएबल सेपरेशन झाल्यानंतर इंटिग्रेशन घ्यायला सोपं जातं होतं. सो दिस इज द व्हेरिएबल, दिस इक्वेशन is in the variable separated form. Variable separated form, because h is a function of y, g is a function of x. If we consider, let phi of x be the solution of, phi of x is the solution of some interval containing a point x0. Let, now if we suppose that form, if phi of x be a real valued function, see this, phi of x be a real valued function which is the solution of equation 2, on interval I, containing a initial point, suppose containing एक मिनट, हाँ, containing a initial point, a point x0 means, suppose it is initial solution, initial point. If you are not consider x0, there is also no problem. Now we have considered phi of x is the solution of this differential equation 2. Then we can write this differential equation as h of phi of x. Phi of x means y is the solution. अगर हमारे पास डिफरेंशियल इक्वेशन dy बाई dx होता है तो उसका सॉल्यूशन y भी हम लिख सकते हैं, phi भी लिख सकते हैं. नाउ इक्वेशन 2 में y की जगह पे आप phi of x लिखो, phi of x into y dash means phi dash of x, which is equals to g of x. So this is also in the separation variable form. Now by taking the integration, so आता याचं इंटिग्रेशन घ्या, इंटिग्रेशन फ्रॉम x0 to x h of phi of t dt, h of phi of t into phi dash of t dt. We can write integration from x0 to x in the interval of I. So we have to convert this into the t, x0 to x g of t dt. Suppose this is equation number 3. Now we can find the solution. Now our aim is to find the solution. So actually on the left side see, there is a substitution form of integral. f of phi of t into phi dash of t असेल, then that form is called as a integration by substitution method. So put x, put u is equals to phi of t in the integral of left side of equation 2, equation 3. हां, आता सांगा रे, मी काय ठेवलं, u ठेवलं, तर इथं काय होतं पहा, phi of t is replaced by u, phi dash of t is replaced by u dash mu phi of t. Then see here in this integral, इथं जे इंटिग्रल आहे x0 to x, these are the limits for t. If we substituted variable u is equals to phi of t, then our limits will also changes. In place of x0, in place of t, put x0, the new limits will be phi of x0. Upper limit of this integral is x, though new limit of this x will be काय येईल पाहता, phi of t. So this can be written as integral from phi of x0, हे लिमिट आपले बदलायचे राहिले होते, to phi of x, which is equals to h of u into du, which is equals to integral from x0 to x g of t into dt. Okay, if we put u is equals to phi of t in the given integral, see this, if we put u is equals to phi of t, u is equals to phi of t, then there are two limits, lower limit is x naught, upper limit is x, then it will also going to change, that will also changes according to our substitution. Now lower limit is x naught, for t is equals to x naught. If t is equals to x naught, then u साठी काय होतं, u is equals to phi of x naught, say this, and upper limit is t is equals to x, then u is equals to phi of x. So we will get the new limits phi of x naught to phi of x, h of u into du, which is equals to integral from g to t. हे फक्त एवढाच पार्ट आपला इंटिग्रलचा विसरला होता. Now this is the required solution हो सकता है. Now conversely suppose that x and y are related by the formula. Suppose we consider x and y are related by using the formula, that is integral from y0 to y, h of u into du, which is equals to integral from x0 to x g of t into dt. We have given the relation between x and y on the same integral, and this defines the implicity, means variable separation form of differentiable function phi for x in I. Therefore this satisfies, this function See this, how we can write this function also? We can write in the form of y0 to phi of x h of u into du, which is equals to integral from x0 to x g of t into dt. So, for all x in I, and we get the differentiating, we get, how we can write, that is h of phi of x, h of phi of x into phi dash of x, which is equals to g of x. And this shows that phi is the solution of, see this shows that the phi is the solution of, this shows that the phi is a solution of, or we can write phi of x is a solution of given differential equation, 2. Now, in actually we can write this, actually we can write, or in practice actually we can write the solution of equation 2. आता ह्याचं जे 2 चं सोल्युशन आहे, we can write in the direct integration form h of y into dy, which is equals to g of x dx. That is by integrating, that is integration of h of y into dy, which is equals to integration of g of x into dx. Now, suppose that directly we can find the solution. So, if according to the statement of the theorem, आपल्या statement काय दिलं, h dash चा जर derivative means we have given capital H of y, which is equals to capital G of x plus constant of integration c, where capital H dash is equals to small h and capital G dash equals to small g, comma c is a constant, c is constant. So, in shortly we can write, and therefore we can get the solution in this form. So, we can say this equation is, suppose 3, suppose 3 हो गया वो, ये हो गया 4, 4 is the solution, and suppose this is a 5. Thus, equation 5 is the solution of is also a solution of differential equation 2, is a solution of differential equation equation 2, and hence we can prove, or hence we can write this, and hence proved. And hence proved. Okay, this is the simple actual solution, which how to find? By taking the integration, we can directly written as the solution h of y is equals to g of x plus c. And this first part, this proves the phi of x is the solution of the differential equation 2. This shows that phi of x is the solution of differential equation 2. परंतु प्रॉब्लेम सॉल्व करण्यासाठी स्टुडंट लक्षात घ्या, प्रॉब्लेम सॉल्व करण्यासाठी आपल्याला ही सेकंड मेथड सॉल्व करायची आहे, फक्त सेकंड मेथड वापरायचे. तर आपण प्रॉब्लेम सॉल्व करू, खूप इझी आहेत प्रॉब्लेम. So we shall discuss the problem. Find the solution of following differential equations. त्यातला फर्स्ट प्रॉब्लेम, y dash equals to suppose y square. This is the first problem. Now our aim is to find out the solution of a differential equation. Path theorem. We have to solve each and every problem by using this method. या मेथड मध्ये जायचं नाही. This is only the proof. हा जो थेरम आहे ना, हा थेरम प्रूव्ह करण्यासाठी फर्स्ट पार्ट मध्ये आपण ऍक्च्युअली वी हॅव प्रूव्ड द phi of x is the solution of a differential equation in this way. Phi of x is the solution of differential equation. We have proved in the first method, but in the second method we can find the solution h of y is equals to g of x plus c, and this is directly by taking the integration, by integrating. वाटलं तर इथं लिहा, by integrating. So we have to use this second method. Write down, given differential equation is खूप सिंपल प्रॉब्लेम आहे. What is that? Y dash equals to y square. First of all, we have to separate this. Y dash means dy by dx, which is equals to y square. Now separate this variable, so we can write dy upon y square. हे dy म्हणजे लेफ्टला, राईट साईडला dx. ओके, म्हणजे काय, व्हेरिएबल सेपरेट करत असताना लेफ्टला टोटल वायच्या टर्म कलेक्ट करा, राईटला टोटल एक्सच्या टर्म्स कलेक्ट करा. मग आता त्याचं इंटिग्रेटिंग घ्या. बाय इंटिग्रेटिंग so we get the integration of dy upon y square, which is equals to integration of what, that is dx. So 1 upon y square, we can't find directly integration of 1 upon y square dy, which is equals to integration of dx. So 1 upon y square can be written as y raised to minus 2. हाँ चला रे स्टुडंट सांगा, सर्वांनी सांगायचं y raised to 2 चं इंटिग्रेशन काय किंवा y raised to n चं इंटिग्रेशन काय असतं. Now you tell me the formula. Y raised to n plus 1 divided by n plus 1. So y raised to, you can take the integration directly, y raised to minus 2 plus 1 divided by minus 2 plus 1, which is equals to dx integration x plus constant of integration c. So we can write this as y raised to minus 1 divided by minus 1, which is equals to x plus c. So minus 1 upon y, which is equals to x plus c. रेसिप्रोकल घ्या दोन्ही साइडचा, मायनस y, which is equals to 1 upon x plus c. आता राइट साइडला घ्या, मायनस राइट साइडला घ्या. सो y is equals to minus 1 upon x plus c, or we can, it is also written as y is equals to minus inner bracket x plus c bracket raised to minus 1. This is the required solution of differential equation of given differential equation. Okay, now we shall take the second problem. आता आपण दुसरा प्रॉब्लेम घेऊ. Second problem. Also we have to find out the solution. Y dash equals to 3 into y raised to 2 by 3. Answer. given differential equation is y dash equals to 3y raised to 2 by 3. Same process we have to use. Theorem madla jo dusra part hai na, actually we have to find the solution by using the theorem, and in that theorem we have seen the second part, direct find out the integration. So first of all we have to use the variable separation form. First of all we have to convert in the form of variable separation. Y dash means dy by dx is equals to 3 into y raised to 2 by 3. So dy is equals to 3 into y raised to 2 by 3 into dx. But this is not a variable separated form, because on the right side there is a dx. So we have to collect all the terms of x on right side and all the terms of y on left side. So dy divided by y raised to 2 by 3, which is equals to 3 into dx. Now this is the variable separated form. Now by integrating, आता एकदा जर variable separation form झालं तर integration घ्या. By integrating कसं येईल मग integration, that is y raised to 2 by 3 dy, which is equals to integration of 3 into dx. 1 minute. Dy divided by y raised to 2 by 3, that is y raised to minus 2 by 3 dx, which is equals to 3 in okay, this is y. So आता integration सांगा रे, minus 2 by 3 plus 1 means it is 1 by 3. So integration is y raised to 1 by 3 upon 1 by 3, which is equals to dx integration असतं x 3x plus c. So we can write 3y raised to 1 by 3, 3y raised to 1 by 3. 1 minute. बरोबर आहे का रे वा? So that will be काय येईल पा 3x plus c. So y raised to 1 by 3, which is equals to 3 न divide करा x plus c by 3, or we can write this c dash कारण आपल्याला replace करायचे. So y raised to 1 by 3, which is equals to x plus c. इतर कारण द्या, c is equals to c dash divided by 3. So we get the solution y is equals to दोन्ही साइडचा क्यूब घ्या x plus c bracket raised to 3. This is the required solution of differential equation 1. See the student, c dash कधी बदलायचं, c ला c dash मध्ये कधी बदलायचं, जर कॉम्बिनेशन अगर हमारे पास if there exists a combination of again constants, due to the division of these three we will get the combination of the constant c dash by 3. c dash is a constant, c is a constant. In such a cases we have to use constant of integration as a c dash and then replace in the form of c. Okay, अशा पद्धतीने हे सोल्यूशन होतं. समजतं का? काय अडचण आली तर विचारा रे स्टुडंट्स, तुम्हाला जर काही अडचण आली तर विचारा. नेक्स्ट वी शॅल डिस्कस द नेक्स्ट प्रॉब्लेम. आता याच्यावरचे बरेचसे प्रॉब्लेम आहेत ते आपण उद्याला घेऊ. क्वेश्चन टाका. Second question, find all the solution, all the real valued solutions of the following differential equation. Following differential equation. त्यातलं पुन्हा first, or we can take small a, y dash equals to x square into y. Okay, see this. Given differential equation is y dash is equals to x square into y. Suppose this is 1. Now we can use the variable separation form method. So y dash means dy by dx, which is equals to x square into y. Now separate this variable dy upon y, which is equals to x square into dx. We have to find out all solutions. All solutions means which includes arbitrary constant c. So by integrating, सिंपल प्रॉब्लेम आहे, तुम्ही ते सॉल्व करा चांगल्या पद्धतीने. इंटिग्रेशन ऑफ dy अपॉन y. सांगा रे 1 अपॉन y चे इंटिग्रेशन विथ रिस्पेक्ट टू y काय असतं स्टुडंट्स? विच इज इक्वल्स टू इंटिग्रेशन ऑफ x square into dx. Also you tell me what is the integration of x square. So 1 upon y चे इंटिग्रेशन, that is a log y, which is equals to x square चे इंटिग्रेशन x cube by 3 plus c. Okay, x cube by 3 plus c. So you can write this as log y. log y म्हणजेच काय लिहिता येईल? एक्सपोनेन्शियल फॉर्म मध्ये घ्या. y इज इक्वल्स टू, व्हेरी गुड, e raised to x cube by 3 plus c. So y is equals to e raised to x cube by 3 into e raised to c. We can convert this constant as dash. So y is equals to e raised to x cube by 3 plus e raised to c dash, means we can put c. E raised to c dash, which is the constant term, we can put c. This is the required solution. या पद्धतीने आपण याला रिक्वायर्ड सोल्यूशन करू शकतो. काय अडचण आहे का याच्यामध्ये? पहा, सी डॅश कधी बदलायची? जर गरज पडली तर सी डॅश मध्ये बदला, नाही तर गरज नाही आहे. इफ यू वॉन्ट टू कन्वर्ट इन द सी डॅश, देन यू कॅन कन्वर्ट, नाहीतर आय जी टीच ठेवलं तरी काही अडचण नाही. हे जरी असं सोल्युशन ठेवलं तरी चालतं. दिस इज द रिक्वायर्ड सोल्युशन. सी दिस, this is the required solution. इथं into येईल, into, 1 minute, sorry, इथं into येईल, means we can write this also, that is y equals to c into e raised to x cube by 3. आणखी याला सॉल्व करता येतं. this is the required solution. आणखी कसं करता येईल? e raised to x square x cube डिवाइड बाय, आता डिव्हिजन आहे ना, डिव्हिजन एक्सपोनेन्शियल मध्ये e raised to -3 येतो, -3 c into e raised to -3 means अगेन c. म्हणजे फायनल आन्सर y इज इक्वल्स टू c into e raised to x cube. या फॉर्म मध्ये सुद्धा लिहू शकता, काही अडचण नाही. ठीक आहे. नेक्स्ट b, y into y dash, which is equals to x. We shall write given differential equation is y into y dash, which is equals to x. That is y into y dash means dy by dx, which is equals to x. So we can separate this y into dy, which is equals to x into dx, by integrating आता इंटिग्रेशन करा. सो इंटिग्रेशन ऑफ y इंटू डी वाय विच इज इक्वल्स टू इंटिग्रेशन ऑफ x इंटू डी एक्स. आता yचं इंटिग्रेशन काय येईल पहा, वाय स्क्वेअर डिवाइड बाय 2 विच इज इक्वल्स टू इंटिग्रेशन ऑफ x that is x square divided by 2 plus c dash. So multiplying this 2, y square is equals to x square plus 2 into c dash. Now 2 into c dash can be written as c. So y square equals to x square plus c. We can write since 2c dash is equals to c. So the required solution is y is equals to root of x square plus c. This is the required solution. रचना भागवत तुम्ही नाही रेग्युलर व्यवस्थित मध्येच कधीतरी येतात. सो दिस कॅन बी ऑब्टेन द सोल्युशन. अशा पद्धतीने हे सोल्युशन होतं. See this, there are number of problems in such a way that we shall discuss tomorrow. तर आज इथं थांबवत बाकीचे प्रॉब्लेम आपण उद्याला घेऊ. ते